In southern Louisiana, a wide body of fresh water named Lake Peigneur stretched across more than 1,300 acres of land. The water was peaceful and calm, surrounded by lush green trees and quiet marshland. Local fishermen floated across the smooth water in small wooden boats every morning to catch freshwater fish. Children played along the sandy shores while birds flew over the quiet, shallow bayou. But beneath that peaceful landscape, valuable reserves of crude oil sat trapped deep underground. They hired a specialized drilling company to build a huge floating oil rig on top of the lake. Tugboats slowly towed the giant metal barge onto the calm water and anchored it firmly in place. A tall steel derrick tower stood high above the water, visible from miles away along the shore. Workers in hard hats moved around the deck, preparing heavy machinery for the long drilling project ahead. The plan was simple: drill straight down through the lakebed until they reached the valuable oil pocket. Crew members assembled long sections of hollow steel pipe right in the center of the rig tower. At the bottom tip of the first pipe section, they attached a specialized cutting tool called a bit. This massive solid steel drill bit measured 14 inches wide from one side to the other. Loud diesel engines roared to life, shaking the metal deck and sending black smoke into the air. The heavy steel shaft began to spin rapidly as the operators lowered it into the calm water. Down below, the spinning 14-inch bit sliced into the soft mud at the lake bottom. Thick gray silt swirled into clouds underwater as the sharp cutter pressed deeper into wet clay. Foot by foot, the heavy metal tool ground through layers of soil far below the floating barge. Up on the surface, crew members checked pressure dials and monitored the smooth rotation of the pipe. However, nobody on the surface knew about the massive secret structure hidden beneath the lake floor. Directly below the lake sat an enormous active salt mine with miles of cavernous underground tunnels. Hardworking miners drove heavy trucks through huge hollow chambers carved out of solid white rock salt. Only a layer of soil and rock separated the heavy lake water from those vast empty caverns below. Unaware of the danger, the rig operators kept pushing the spinning drill deeper and deeper into the earth. Suddenly, far below the lake floor, the smooth turning motion of the steel pipe jolted to a halt. The entire floating rig shuddered violently as the heavy diesel engine strained against extreme resistance underground. Needles on the control panel gauges spiked dangerously as mechanical strain built up along the spinning shaft. As the drill bit snagged far beneath the surface, the workers on the platform had no idea they had just opened a drain plug above a giant subterranean cavern. The tiny drill bit punched straight through the ceiling of an active rock salt mine. At first, the puncture mark was only 14 inches wide. Fresh lake water immediately began trickling down through the small circular opening. Beneath the peaceful lake lay massive, solid pillars of pure rock salt. When fresh water touches solid salt, the salt dissolves almost instantly. Salt is a natural mineral that dissolves rapidly when hit by plain water. The rushing water began melting away the edges of the narrow drill hole. Air trapped in the underground tunnels blasted out through nearby shaft openings. Geysers of displaced air shot high into the sky near the shoreline. The vortex continued to grow, acting like a giant open drain in a bathtub. Nearby wooden barges and fishing boats were dragged toward the churning center. The surrounding shoreline began sloughing off and sliding straight into the water. Tall trees and muddy banks collapsed into the growing vortex, one after another. Millions of gallons of fresh water flooded into miles of underground salt tunnels. The lake level dropped rapidly, exposing mud flats that had been submerged for years. What started as a 14-inch mistake had turned into a terrifying natural whirlpool. As the lakebed gave way and swallowed the entire drilling platform, an even worse subterranean structural collapse was taking shape underground. Back on land, frantic engineers gathered inside a crowded office trailer to examine giant blueprint maps. They needed to answer one single, critical question before the sun went down. How could a shallow drill bit strike an underground mine that was supposed to be far away. The oil company had hired professional surveyors to plot the precise location of the drilling barge. These surveyors relied on coordinate reference systems to pinpoint locations on the surface of the Earth. A coordinate system uses invisible grid lines numbered like a graph to identify exact geographic positions. Mapmakers draw these grid lines so workers can match paper blueprints to real spots on the ground. However, mapping the round surface of the planet onto a flat sheet of paper creates distortions. To solve this problem, mathematicians created different grid projections customized for specific geographic regions. In Louisiana, two main coordinate projections were widely used by local land surveyors and state planners. One projection system adjusted grid lines for the southern zone near the coast. A different projection system used slightly different starting coordinates for regional mapping projects across the continent. When the oil team began planning the lake drilling site, they pulled data from two separate maps. The first map used the local state projection system, while the other map used the nationwide reference grid. Then, a catastrophic human error occurred during the engineering review process. A draftsman copied numerical coordinates from the state grid directly onto a different reference map. They failed to perform the necessary mathematical conversion between the two coordinate systems. On the flat sheet of paper, the grid lines appeared almost identical to the human eye. The mistake looked like a minor shift equal to less than 1/fraction of an inch on paper. But when scaled up to real-world dimensions, that tiny paper error multiplied into a giant distance gap. The incorrect calculation shifted the intended target point across the water by hundreds of feet. The oil crew believed they were safely positioned far away from any underground salt mine tunnels. Their paperwork indicated that hundreds of feet of solid earth separated the drill bit from the mine. In reality, the drilling barge was anchored directly over an active shaft of the salt mine deep below. When the 14-inch steel bit pressed into the lake floor, it did not hit solid rock. It punched straight into an open room inside the salt mine where workers had dug years earlier. Cold fresh water immediately rushed down through the newly opened pathway into the cavern. Salt dissolves rapidly when exposed to flowing fresh water in large quantities. The rushing water immediately began melting massive salt pillars supporting the weight of the rock above. Pillars that were tens of feet thick dissolved into soft liquid salt in a matter of minutes. While engineers pieced together the mapping mistake, the dissolving salt pillars subterraneanly collapsed, triggering a terrifying chain reaction on the surface. The massive underground collapse swallowed every single drop of fresh water from the shallow lake. Where a peaceful body of water once stood, only a giant empty muddy crater remained. However, the subterranean salt mine deep below was still empty and far from full. The empty void underground still needed millions of gallons of liquid to fill its huge shafts. A short waterway called the Delcamber Canal connected the lake directly to the ocean. A canal is a man-made water channel that allows boats to travel between different bodies of water. Under normal conditions, fresh water from the lake flowed outward through this channel into the sea. That natural movement of water was about to flip around in just a few seconds. The massive empty cavern created an extreme pulling force at the bottom of the lake bed. This sudden drop in pressure reached all the way to the entrance of the ocean channel. First, the outward moving water in the canal came to a complete and sudden standstill. Then, the unthinkable happened as the entire canal reversed its direction completely. Dense salt water from the Gulf of Mexico began surging backward through the narrow channel. The ocean was now rushing inland to fill the giant hole carved into the earth. As millions of gallons of ocean water flooded inland, it reached the rim of the lake. The surging water poured violently over the muddy cliff into the empty cavern below. This massive flow created a 50-foot waterfall cascading directly into the deep sinkhole. Louisiana is mostly made of low, flat land, so waterfalls are almost never seen there. Because of this extreme event, it became the tallest waterfall ever recorded in the state. The roaring waterfall slammed into the exposed salt walls with incredible force. Air trapped inside the deep mining shafts was compressed and forced out by the water. Bursts of mud and air shot high into the sky like violent underground geysers. The violent rushing water churned with immense power, tearing away at the surrounding land. The fast-moving current began eating into the soft soil of the canal banks. Enormous chunks of muddy earth broke off and tumbled into the rushing flood. Commercial boats operating near the canal were completely caught by surprise. Large, flat metal barges floating in the channel could not fight the sudden backward pull. The irresistible suction dragged the heavy industrial vessels directly toward the roaring edge. One after another, the massive steel barges tipped over the drop and plunged underground. As the ocean water filled the subterranean mine, it dissolved even more salt pillars. With the salt pillars melting away, deeper mining tunnels began collapsing under the weight. This secondary, underground collapse caused the outer edge of the sinkhole to expand rapidly. A famous botanical garden located along the shoreline began tilting down toward the water. Ancient pecan trees that stood on the shore were ripped out by their roots. Waterfront homes cracked in half as the ground beneath their foundations washed away. Entire docks and parking lots slid down into the widening salt water whirlpool. Geologists watching the destruction unfold could not believe how fast the land was disappearing. The continuous influx of ocean water was permanently changing the chemistry of the region. What was once a shallow freshwater lake was rapidly transforming into a deep saltwater bay. 9 barges, trees, and land structures vanished down the abyss, leaving experts unsure if the surrounding terrain would ever stabilize. When the churning water finally stopped rushing, an eerie quiet settled over the landscape. What had been a calm freshwater lake was now completely replaced by open saltwater. Ocean tides from the Gulf of Mexico swept freely through the wide new bay. The massive hole beneath the lake had swallowed millions of gallons of water. The hollowed salt mine caverns were filled completely with heavy ocean water. Over 1,300 acres of freshwater habitat vanished in less than 2 days. The sudden arrival of salt killed off native fish species almost immediately. Freshwater plants decayed quickly as high concentrations of salt poisoned the water. Marine species like redfish and blue crabs quickly populated the newly formed bay. Ancient cypress trees along the edge died as salty water soaked their root systems. A famous botanical garden on the shore lost large sections of land forever. Before the drilling accident, the lake maintained a shallow depth under 10 feet. The deep collapse crater measured over 200 feet at its lowest point. That sudden depth change made the lake the deepest body of water in Louisiana. Heavy machinery and industrial vehicles remained permanently trapped beneath the floor. 9 massive barges and a complete oil drilling platform sat buried in silt. Sunken tugboats rested alongside structural debris in the dark, flooded salt caverns. Remarkable luck prevailed despite the massive scale of destruction across the region. 51 underground salt miners managed to reach the surface before caverns flooded. Drill rig workers safely boarded boats right before their platforms slipped underwater. Houseboats and dock structures near the canal shore were sucked into the growing vortex. Legal battles began immediately as affected landowners demanded answers and compensation. The oil company and drilling contractors paid out tens of millions in damages. Salt mining under the lake was permanently shut down to prevent future collapses. The once thriving salt production facility stood empty beside the newly formed bay. Engineering boards conducted rigorous investigations into the root cause of the tragedy. They traced the disaster back to a mismatched geographic coordinate system map overlay. Project planners had relied on custom grid references instead of universal state coordinates. A simple mapping error had miscalculated the position by several hundred feet. That small spatial error sent a 14-inch drill bit straight into active workings. Today, the quiet surface conceals the dramatic geological history sitting beneath the water. Fishermen regularly navigate over the deep pit without seeing the sunken ruins below. Satellite images clearly show the altered coastline where land dissolved into the lake. New marsh vegetation gradually grew along the modified brackish water shorelines. Environmental monitoring stations continue testing the brackish water for long-term changes. While the physical scar remains permanently visible today, it leaves us with one lingering question. How many other underground mines rely on outdated coordinate systems?